Welcome to the second part of exercise set 5. Today, we'll continue exploring core OOP concepts, diving deeper into inheritance, introducing abstract classes and abstract methods, and seeing how they enable powerful polymorphism in C# through property and method overriding. Let's begin by part 1. Our first problem, the cookie demo, involves managing cookie orders for Nina's Cookie Emporium using classes. We need a base class cookie order and a derived class special cookie order. The cookie order class needs properties for order number, recipient name, cookie type, and fields for the number of dozens ordered and the price. A key requirement is that when the number of dozens is set, the price field is automatically calculated based on a tiered structure, $15 per dozen for the first two and $13 for each dozen after that. This calculation logic is tied to setting the dozens value, encapsulation, and logic in property setter. This shows how logic can be encapsulated within a property setter, linking data modification to behavior. The special cookie order is a child class of cookie order, inheriting its members. It adds a field for a special description, inheritance. This establishes an is-a relationship. A special cookie order is a cookie order. The special cookie order needs to override the method that sets a cookie order's price. This means it needs to override the setter for the dozens property. The overridden setter should perform the base price calculation from cookie order and then add an additional special handling fee, $10 for orders up to $40 base price, $8 for higher priced orders. Polymorphism, overriding property setter. Overriding a property setter allows the derived class to customize the behavior that happens when a property is set, building upon or replacing the base class's logic. We'll create application classes to demonstrate both. Let's look at the base cookie order class code, properties, fields, constants, auto-implemented properties for basic details, a private dozens field, and a protected price field. Protected means special cookie order can access it, dozens property setter logic, the public int dozens property. The set accessor contains the logic to calculate the base price based on the number of dozens assigned to the private dozens field. This demonstrates encapsulation with calculated data triggered by input. Simple test. Objects of cookie order are created, their properties including dozens are set, and then a display method, shown below, is called to print the details. Setting the dozens property automatically calculated the price based on the logic in the setter on the previous slide. Now look slide showing the cookie order class again. The difference is public virtual int dozens, virtual keyword. Adding the virtual keyword to the dozens properties declaration is crucial. It signals that this property's getter and/or setter can be overridden in a derived class. Without virtual, overriding wouldn't be possible. This prepares the base class for polymorphic behavior. Here is the special cookie order class, inheritance. Class special cookie order : cookie order, new property constants. Adds the special description property. Add constants for the special handling fee tiers, overriding dozens property. Public override in dozens, overriding property setter. The override keyword means this dozens property replaces the virtual dozens property from the base class. Specifically, its set accessor will execute when dozens is set on a special cookie order object, extending base logic. Inside the setter, essentially repeat the base class's price calculation logic based on dozens, then add the special handling fee based on the calculated price if price less than price cutoff. This demonstrates how an overridden member can extend the behavior defined in the base class. Slides show the test code for the cookie classes. Object creation. Both cookie order and special cookie order objects are created. Setting their dozens property triggers the appropriate price calculation logic in each object's specific type setter. Because special cookie order inherits from cookie order, we can pass either type of object to this single method. Polymorphism with display method. Look at the display method signature, public static void display, cookie order order. Polymorphism base type reference. This method accepts an argument of the base type cookie order. Runtime behavior. Inside the display method, notice the code if order is special cookie order special order. This uses the is operator to check the actual runtime type of the object. If it is a special cookie order, it casts it and displays the special description. When order.dozens or order.price are accessed, the properties of the object's runtime type are used, triggering the overridden dozen setter logic if it's a special cookie order. This demonstrates how polymorphism allows a method designed to work with the base type to correctly handle and interact with objects of derived types. Alright, that wraps up our look at the cookie order problem, where we practiced inheritance and saw how overriding property setters lets a derived class customize behavior. Now let's move on to our second problem in this set, the shapes demo. This exercise will take our understanding of inheritance and polymorphism even further by introducing the concept of abstract classes.